So far, reports suggest the ship lost propulsion as it left the port, and the crew on board had warned Maryland officials of a possible crash. Well, for more on this, let's go to civil and structural engineer Julian Carter. Julian, we were talking earlier on to a maritime safety expert about how often you get these failures on board vessels, and thankfully they are all too rare given the safety checks that they go through, rather like aircraft. But then looking at these pictures, one doesn't expect a bridge of that magnitude to just crumple like a pack of playing cards. Is that a normal thing to see, or was there some sort of structural weakness with that bridge?
It's that form of structure is very delicate. It's a continuous structure. One of the main spans was about, I believe, 800 feet. And it is a lightweight truss structure which relies on every part working very, very hard. And realistically, the ship, you imagine 50 years ago when it was designed, cargo vessels were not the size that they are now. 50% of this possibly. And you imagine when it struck one of the piers, one of the main central supports, it's effectively where it wants to talk to itself across that pier, it severed the link. And that's where you've got an immediate catastrophic failure. It's a very lightweight structure, and there's very little what we call residual strength in it, other than its pure job.
So what we're watching as we see this very dramatic collapse is a kind of a chain reaction that extends from where the collision happened, yes?
Yes, because effectively the way this form of structure is constructed, every part connects to every part. Structurally, they're all connected and interconnected. There is no break. And what you've got here, that pier, it will have pushed it over. It would have taken it out of its main plane, and it just simply collapsed, simply folded is the easiest way to describe it. They weren't doing structural repairs at the time. It's been said they were doing pothole repairs. So one can imagine, like the UK, we have principal bridge inspections and principal bridge assessments. I would expect this to be effectively in its tip-top condition.
Are we therefore chalking this up to essentially a freak accident? We don't know what's happened on board that huge vessel. I was saying earlier on in the show, megalithic structure, that thing, when you look at all the shipping containers on it. Or do we across the West have to call into question some of our structures that are sort of now getting rather old, and whether they're still compatible with today's mass movements? And I mean, vehicles are much heavier. Electric vehicles are double the size of the old combustion engine vehicles. Like you said, when you look at things like that cargo ship and the sheer amount of stuff on board and the size of it, do we need to be looking at things built a number of years ago and asking whether they can still function in a situation like this?
Yeah, I mean, when you look at something like that, the actual vehicular traffic as a load is probably only 5–10%, maybe 15% of the total loads that were around, because of the big spans. Now, yes, the amount of energy that would be in that boat as it collides is absolutely phenomenal. But let's look at the conditions. It wasn't cold. It wasn't below zero. We're not looking at -10 and -15, where we had many failures in the 1960s and 70s of what we call brittle fracture. It wasn't as though it was, the coldest night on record. It was blowing heavy wind, extra cooling, and then it fractured through the temperatures. These are newer bridges typically. Who knows what the investigation will bring? But you make a very good point. Yes, your standard vehicle is 2.5 tons now with all its batteries, car parks and their spaces. There may well be a review by the ports who are looking at their fendering and looking at pier protection. And unfortunately, this is an event where we learn safety by accident. This was probably never considered in the original design, and may well, from a common sense perspective and diligent engineering, now make owners and users consider reassessing their structures, which is common sense.
I was going to say that, Julian. I mean, I don't know what kind of bridge this is. I think it's called a steel truss bridge or something like that.
Yes.
So this vessel, this rather large cargo ship, did hit it, but it was hardly the collision of the century. So that vessel could be described as, you know, normal cargo traffic. I mean, my question to you, I guess, is, given what happened there, are steel truss bridges fit for purpose in today's modern age? Do we have to think about getting rid of them all?
I wouldn't think so. What we'd have to do is go back and look at the original design intent, and I'm sure that's what the authorities will be doing now, and saying, okay, what is the delta? You know, the ship that caused that impact, what is its difference in size? And I think it may well then elicit. Let's bear in mind, we did this in the UK when all our roads had to take 45-ton vehicles, and we had a thing called Operation Bridge Guard across the whole of the UK, where all our critical national infrastructure and bridges were assessed for their strength. That's been done. And our design codes are up to date in the UK. There will be some assessment work. That's normal and appropriate. But that will just unfold in time. There are very few. I mean, we could take Manchester and the Manchester Ship Canal, the Thelwall Viaduct I worked on as a graduate. That certainly has been designed for those kind of collisions, and other inland waterways that we have in the UK. I'm sure the ports authorities will now undertake assessments of the traffic and risk a new round of risk assessment.